and co-founder of Future Compass, and welcome to another episode of 0 to 1 Podcast. I'm here with a very special guest. This person has done some incredible things in the aerospace industry. This is Rowland Reeves, CEO and co-founder of US Space. Rowland's has a very interesting case. He's gone from someone who has basically every reason to not start something into someone who has used that and gone, fuck it, let's hit it with the baseball bat, let's start a thing. Roland, tell people about yourself.
Well, just trying to make the story as short as possible, and then probably expand on it a little later. But basically, I was for this venture that we're on right now, the U.S. Space Corporation. We started the research for this in 2017, in the summer of 2017, and I had just retired as a computer and tech teacher. That was my career. And my co-founder, who's also my son, and I spent the summer of 2017 not in a typical manner, but we did very, summer things and family stuff and everything, but we spent hours and hours on probably 100 or more than 100 hours looking at the U.S. space industry and looking at space industry in general, rocket engines, launch vehicles, the thrust of the space industry. And we came up to the conclusion that there were some really major flaws in multiple aspects of the space industry, the rocket engines, the launch vehicles, the thrust of the industry. And that created in us this grinding frustration. And that was also enhanced by the fact that they had terminated the shuttle program and they weren't going to renew it or improve upon it. And so there was just all kinds of things. So on November 8th, 2017, we decided to do something about it. And we started looking into possible solutions to these problems that we had, felt that we had discovered or, felt that we saw in the space industry. Fast forward to 2023, after literally thousands of hours of research, learning curves.
I do want to stop you for a second. What problem did you find earlier in the space in 2016? Good. What problem did you find specifically?
Right. Also, I'll just tell you right now, be sure and interrupt me if you have a question, because otherwise I'll go on for hours. So.
Yeah, no, I want all the fucking details, every little bit, every little everything. I do not care. We're getting all this, right? This is gossip over here.
Yeah. So it's not hurting my feelings if you, say, hey, Roland, stop for a second. Yeah, what we found we'll go, because this is what we're focused on right now, is the rocket engine. Rocket engines technology, all rocket engines right now in really the world run on, they have a problem. It's the back pressure from the rocket engine up into the pumps that feed them. So the pumps are feeding the fuel in. The rocket engine is, all the combustion's going on, and all that thrust that's going out the bottom. Well, guess what? The same amount of thrust goes back. The exact same amount. It goes, both ways. So the back pressure is pushing against the pumps. Well, that means the pumps have to actually put force into the engine at a higher pressure than the engine is producing. That is enormously challenging.
So can you explain back pressure? So back pressure is like these straws, as far as like in effect with straws coming up, right? So you have typical rocket design is like the straws will pull from the tanks into the engine that's having it burn. But back pressure is what's caused with like over here in this section, right? Where the atmosphere is being pushed against it and is causing a lot of like, almost like having a brake on, like an air brake on, while you're trying to propel this like 300 metric ton vehicle up in outer space.
Right.
So nothing major, right?
Yeah, nothing major. In fact, the pressure that the inside of the combustion, the engine produces can be up to like 350 bar, 350 atmospheres. So
Right.
350 more pressure than is in the atmosphere around it. But of course, that also is 350 atmospheres back up. So the pumps have to pump in at higher than 350 atmospheres.
Hmm.
That is enormous, and that's difficult, beyond words. It's extremely difficult to do. And for example, like on Starship and the Raptor engine and things, the differential between the incoming pressure, which is coming in at about maybe 380, 390 bars,
Hmm.
to the 350 going out, it's a differential in pressure of about 40 bars.
Right.
So that the pumps can't put the fuel in there any faster than about the 40 bar differential between the combustion and what the pumps are generating.
Right.
So,
So you're losing all this energy in order to keep things moving up. But
keep,
there's
yes,
like, I read on your website, it's 62%. Is it exactly 62%, or is it like some decibels here and there?
no, no. Oh, so what are improvements? Oh,
Hmm.
you mean what is being lost?
Yeah.
Well, we figured that it was, somewhere between, when we calculated it, we figured it's somewhere between 30 to 70% of the engine's efficiency is being lost
Hmm.
because it has to, the amount of fuel that can be put in is limited to
Right.
some extent because of the back pressure. So basically, we developed a system that I can't say overcomes the back pressure, but negates the back pressure so that the pumps can pump into the engine at their full capacity
Hmm.
of 380 bar of pressure. And the pressure in our engines when the fuel goes in is only about, it's not 350 bar, it's only about 10 bar.
Hmm.
So the pressure differential between the pumps and our engine is huge, which means the amount of fuel that can go into our engines is much, much greater. In
Right.
fact, it's about 62% more mass flow rate. We can get
Wow.
about 62% more fuel per second into the engine than can than engines now do. And this is counting SpaceX and Blue Origin and everybody. And
Wow.
that's where we get these from our simulations, these massive increase in thrust.
Hmm.
Uh, so
And as a result, you have these like 34% more efficient engines in total, though.
Right.
Right.
The efficiency goes up about our simulations show our efficiency is about 42% higher
Holy shit.
than right. And that is and that's due to well, now I'm getting in a little into the IP and I can't tell you that, but I will be able to tell you that in a
Yeah.
few months. But
Yeah.
the yeah, so our efficiency is about 42% higher and the overall thrust increase is about 62%. And
Okay.
this is through you know, really actually hundreds of simulations we've done on the engine.
Hmm.
And of course that each time we did a simulation, we reiterated the engine, and it finally improved up to that level.
Okay.
Um, and then,
So
and
you
I'll, yeah, go ahead.
so you started in 2016 with a simulation of a launch, and then that's what caused you to kind of discover all these problems, or kind of look at these problems and go, okay, how can we solve them? What simulation did you use exactly?
Okay, so when we first started, we basically we just looked at it theoretically and how a rocket engine works, and of course I knew a little bit about this, but having been a tech teacher for 25 years and that type of thing. And my son was quite savvy in some of these areas too. But still, we're untrained aerospace engineers. But
Hmm.
intuitively, looking at the engine, we thought, there's got to be some huge waste here or lost opportunity because the pumps have to work so hard
Hmm.
just to get that fuel in there. So basically, what we started doing when we finally started designing the engine and everything is we ran the simulations, and the it took us about 6 months to design the simulation program.
Hmm.
And we wanted a 1 second by second review of how the engine worked each second of its operations from the ignition up to MECO, main engine cutoff.
Hmm.
Uh, uh, that goes, anywhere depending on your flight and everything. It's up to 180 seconds, to up to 200 seconds for that. And so we wrote a simulation in Excel, and we ran the simulation against the results that the Falcon 9 rockets were getting. And the simulation finally matched exactly, very, very closely to what the Falcon 9 was doing. And at that point, we knew that we had a valid simulation. So then we took the simulation and ran it on the design of our engine,
Hmm.
with the larger mass flow rate and everything. And that's how we started getting what we felt were very valid results from our testing.
Awesome. So, what did you see as far as the difference between what the Falcon 9 was, like the
Mhm.
original Falcon 9, and then your modified version of it?
Actually, we we don't really have a modified version of the Falcon 9 per se.
Hmm.
We have a modified version of continuous flow rocket engines
Okay.
of any type. It just so happens that the Falcon 9, the engine, is the Merlin engine is the best engine. So we use that. Just like right now for SpaceX, the Raptor engine is the best, and we
Nice.
run our simulations against the Raptor now. Of course, they didn't have, the Raptor was still evolving back then.
Yeah.
But anyway, yeah.
So this
So
is so your simulation was in 2017 is when you guys started running it.
no, we
Hmm.
started running the. It took us years
Hmm.
to get the design right to where we even had an engine that we could simulate. I
Okay.
mean, it was, yeah, we had of course, we're not aerospace trained, so we had a learning curve. And also at the same time, a lot of our time was, we didn't spend all our time on the engine. A lot of the time was spent on redesigning the launch vehicle, is going to be our next um, venture, as the engine now is, as we're developing the engine, we also, we're going to bring out a new launch vehicle.
Hmm.
So um, we finally ended up with a working engine in, what we thought was a working in an engine in about 2022, about
Okay.
5 years afterwards. And
Holy
at the
shit.
same time, we had developed this new launch vehicle. And
Okay.
it was at that time when we started running engine simulations and iterated the engine design, and ran the Falcon 9 launches through our simulation also, that we
Mm.
realized that we felt that we really had something.
Nice.
Yeah.
So in your career, right? Just to
Mhm.
kind of make sure the audience have the context for it. You had 30 years as a middle school and high school computer science teacher, right?
Right.
And then retired. And then it was like, listen, here's what I'm gonna do. Rockets are cool. I'm gonna go into rockets. From rockets are cool, I'm gonna go into rockets and with the engines, right?
Yeah.
What was the first day like when you started work on this thing? Did you just go like, all right, cool, I'm gonna work on an engine because see what
Well,
happens? Are you watching rocket launches in your free time? Like, what's going on here?
well,
What?
well, we were big fans of the whole space program and everything, and of
Hmm.
course, Elon Musk we got to go to Mars to save Earth and all that kind of stuff.
Right.
So we were interested in it, and with that interest, like I said, in the summer, over 2017, over those 3 months, we just spent hours and hours. Oh, this is so cool. But
Yeah.
the more we got into it, the more we started going, wait a minute, geez, that seems like really wasteful, you know.
Oh,
And then
yeah.
the launch vehicle design, we thought, oh
Yeah.
man, that's, you know, we found all these things that we thought were so bad. And it was again on November 8th, 2017, we decided formally, actually made the decision. We're going to start working on this. If we're complaining about this and this is such a, you know, big frustration to us, we
Yeah.
better do something about it. And that's when we actually started. And it was really tough. It was very tough. The learning curve was huge.
Hmm.
And that, you know, it took really years to get up to where we were actually fine-tuning the launch vehicle, fine-tuning the engine. Like I said, we started in 2017, and it was 2022 when we finally felt that we had, you know, achieve some solutions for these things that we had seen 5 years before. I had I had tracked, just out of curiosity,
Hmm.
on November 8th when we started. I thought, you know, I'm gonna kind of track, see how many hours I put into this. You know, I never had the idea that I was gonna quit. You know, it's not like, oh, I want to see how many hours, so when I quit, I'll know how many hours I wasted. No, it was like, I want to see how many hours it takes me to solve this problem. And by 2022, we were up to, at that point, about 7,000 hours that I had logged. And my co-founder didn't log his hours, but he had, you know, huge numbers of hours too.
Yeah.
But, you know, for someone out there who's watching that may have an idea and they're starting, you know, just cold
Hmm.
like we are, that's the kind of time you have to put in to go through the learning curve and of course never give up. You know, all kinds of frustrations and everything.
Yeah.
I'll tell you one frustration story. It was very interesting. We finished what we thought was a complete version of the simulation. We launched our rocket. The rocket went up, but it wouldn't come down in the simulation. It just floated there. And that's when we, oh, we got a big problem here. So
Yeah.
we, you know, we finally, then we started running the Falcon 9 flights through the simulation, and the simulation showed the exact same results that actually occurred when the Falcon 9 took off and came, you know. So that's when we realized we had finally solved that problem. Um, so again, just at any point here, interrupt if you have a
Yeah.
question, because I'll
So,
just be going on and
because,
on. So,
okay, so you have a rocket that is being designed for going up and then coming back down. Reusable
right,
rockets. It's the new wave. It's the new fad.
right.
Just like Heelys back when we had tennis shoes come out, right? Um,
Yeah, yeah,
um,
exactly.
totally a fad, just a fad,
Yeah.
right? Not going to be the mainstream thing for the rest of all time. Um, Insane. And so you have this massive improvement on a rocket engine
Right,
that you've been using, and what sounds like a bunch of 7,000 hours logged
right.
is
Hmm.
insane, but it makes perfect sense to me. Like, because I've been working on myself for like 3 years and I'm over here like, oh, yep, totally makes perfect sense. But I think someone who's
Right.
just starting is going, that's ridiculous. What are you talking about? 3 years,
Hmm.
right?
Hmm.
Or 5 years or however long. But that's really, you have to make a problem personal enough for you to actually be willing to go out and solve it.
Right.
Missionaries versus mercenaries, 100%, right? When it came to getting things rolling on the people side of things, right? So you got to 2022 where you actually had a solid thing. You
Right.
submitted it for grant proposal in 2022 as well, if I'm not
We
mistaken.
very close. The We first, in 2022, we'd kind of had it, you know, formalized what we wanted to do, and then through the first part of 2023, we submitted multiple patent provincial patents on the, you know, on the inventions. And once our patents went through, then we did a cold pitch on the engine. We
Okay.
didn't do the launch vehicle. You know, we're going to work on that once we get the engine running and everything. So we did a cold pitch to the National Science Foundation,
That sounds cool.
SBIR,
Was it
Small
in
Business.
person?
What's that?
Was it in person?
No, no, it's all online. I don't even know if they let you do in person anymore, but it's we weren't invited. I mean, we just cold pitched them out of the blue, you know, two non-aerospace guys
Like some
claiming we
public
had this.
comment?
yeah, claiming we had this super advanced engine, you know.
Yeah. So,
So,
okay, you have, because you mentioned your co-founder multiple times. Who
yeah.
is your co-founder?
My
Um,
co-founder is my son.
yeah,
Yeah,
your
yeah,
co-founder also has a pretty similar background to you as far as like computer science,
right.
working in where do you work in before this?
Well, he just knows computers, and he has no formal training in aerospace at all.
Awesome. I love
Yeah,
this
so
team already. This is
right,
a yeah,
right. Well, this is what it's kind of an interesting story for those people who think they have an idea, but oh, that'll never work. I don't know anything about that. No, really, you can. And of course, you know, especially in something like rocket science, I mean, coming out of the blue.
hmm
So, we hope the story is somewhat of an inspiration to people who have an idea and they feel, oh, I'll never be able to do that.
yeah.
Yeah, you can, But again, I'm telling them, hey, we put in 7,000 hours.
But that's what you have to do, though,
But
realistically speaking. It's not
th-
going to be
yeah,
built overnight. It
no,
wasn't built in a day. It certainly
mm,
took a lot of failures. How many simulations did you run for it to flop
oh,
and burn, explode, and
oh
this,
my
right?
gosh,
Like, how many
hundreds,
did you spend? You know,
hundreds. Yeah,
right? Hundreds,
yeah,
thousands, even. And
right.
I'm sure you're going to watch something go up in the air very soon in the near future and blow up catastrophically and just come
Yeah,
raining down.
yeah. There's a lot of tears. There's a lot of tears
Yeah.
along the way. So yeah, that's true. But you can do it if you're willing to put in the time and and the effort and go through the learning curve. And also reiterate and understand that you have to pivot. You can't, maybe your idea that you first had, the in the details isn't correct. You have to change. And this is what our concept never changed, but the engineering on how we achieve that changed considerably as we ran each simulation and reiterated, and the engines started gelling together, and the concept is there,
hmm
but how do you do the concept? And we finally figured out how to do that.
Nice. So your concept of I'm assuming because I know IP is a huge thing, so we're not gonna get too far into it until later when you get more,
Yeah.
we're able to do it. We'll come back in like 6 months and you'll have a story that I can really
A
look
little
at.
more IP. Yes. Yeah.
Maybe we'll have a video, right? We'll edit
Yeah.
that
Right.
into.
Right.
Um, I'm so excited for it. But you go through all this trouble, like really, really solving problems that
Right.
are, I don't think like, okay, there's a couple things. One, like, where do you get the balls to just go, I'm going to do this and this, oh, like, this is a focus I'm going to go at because it's such a
Uh-huh.
gripe. Like, it annoyed you to such an end where it's like a thing. But that's kind of how it works. It just, you have to get personally irritated by a thing that just, it doesn't make any sense why it annoys you. It just does. And
Hmm.
that's the problem you solve. And then, all this other good stuff comes from it, all this learning and, teamwork and all that kumbaya stuff. But it takes so much more into then going to the NSF, right, National Space Foundation, pitching a thing at a seemingly public comment, how long you waited in line for, right, for them to go, sure, we'll look at it, right, fine, maybe we'll look at it. After they look at it,
Yeah.
kind of, right,
Yeah.
how, like, where's that going?
Okay, so we did our cold pitch. This is your details. We did
hmm
our cold pitch on June 1st, 2023, and exactly 30 days later, on July 1st, 2023, they sent us back an email saying, you're we are interested enough to take a look at your um, project, and this is a formal invitation to present, the formal thing, and this is where we have to show them all the IP and everything. I mean, all
right,
the details, and it was a very grueling process. We finally completed their application forms and everything on November 1st, 2023, literally 3 hours before the deadline. And that's not because we were wasting time we spent those 4 months from July to November just every single day working on completing this application,
Right.
and got it in, and then it was just like silence, for like 3 months. Nothing came back except we've received your application and
Oh,
it is under review. So we
okay.
had 3 months of just kind of
Sitting there.
quiet drama, going, what the hell, what's going on?
What was
Yeah.
going through your head during this time? Was it just like my dreams are dashed or what? Like,
Oh yeah, every possible thing, Oh, they're giving it enough time so they can say we looked at it, but I'm sorry, all the negative things that go
yeah,
through your head. We went through all of those, and then we went through oh, they're looking at it because they're interested in it. So we got this, our emotions were just like this, yeah, just roller coaster.
you went through a breakup. That's what I heard.
Oh,
That's what
yeah.
it sounds like. It sounds like you got a we need to talk text and then just left it there for
Oh yeah,
months.
yeah,
Uh,
yeah. So, then it was around March or so, that we started getting our first letters back from emails back from them asking about the project,
mhm.
getting into the details. In the meantime, we had watched numerous podcasts and YouTube videos on the SBIR process and everything, and I did see a podcast where Greg Shred I have a tough time pronouncing his name.
It's all good.
Anyway, the head of the SBIR
Right.
said that one of the things comment he made in his podcast, he's the head of the SBIR. He said, if you get a response from us very quickly, that's probably a bad sign.
Oh,
But yeah, but the longer you wait, that could possibly be a very good sign. So that little thing right there, which we saw in February, kind of kept us going.
yeah. You were
Yeah.
going, and then you're like,
Yeah.
oh, maybe we'll.
Oh, yeah, this is that.
There's a
So anyway,
chance.
the emails started coming asking, progressively more and more details about it, about the project.
Hmm.
How could we make these just enormous claims for thrust increase when everybody knows even a 5% thrust increase on a rocket that's considered worth millions of dollars. If you can get 5% more, that's worth, put millions of dollars into that because that's huge. And of course, we're claiming 62%.
Yeah,
And these guys at the NSF, these are old line aerospace guys that have been in the industry for 30 years.
and they're
And they
classically
know
trained. They have such a
there's no,
pedigree, and they've
y-
done all this training and all the things. And you're just
yeah,
some ragtag bunch of team of misfits that are like, you're a teacher for goodness sakes. What are you talking about? You know, you're talking 62%. That's ridiculous. And all this time, yeah, this seems like a movie to me, honestly.
yeah,
Like I
yeah.
would. If I didn't know you, if I wasn't talking to you, I'd be like, "Great, where's the episode coming? Where's the TV show?" You know?
Right, right. Well, they just absolutely didn't believe it. And in fact, I'll zip ahead a little bit. Our project manager at the National Science Foundation, when you do a submission, they assign you a project manager. She said that they almost threw the whole application in the proverbial trash, just out of hand, just
Hmm.
because of the claim. But they decided, well, no, we invited him. He's made his claim. Let's look at it, and then we can tell him, go through the brutal details and tell him why this ridiculous idea is not going to work.
Hmm.
So anyway, in March they started asking us more and more and more questions, and we sent back responses in great detail to every one of their questions. We never ghosted them. We never tried to generalize. We gave facts and figures and details.
That's good.
And as the questions got more and more detailed and they began to understand what we were doing and what we had done, uh, the questions started changing from, how is this to how are you going to maximize this? And that's when we knew a little corner had been turned, so to
Hmm.
speak. So this went on for 9 months. It
Yeah.
was grueling. It was just at points it just got very emotionally challenging. And so, but on about
So what questions did
August.
they really ask? I mean, they asked, so
Oh,
some of the things I've heard from like from entrepreneurs is that when investors stop asking questions, that's a bad sign. So you've got them like asking all these questions, but I
Mhm.
know these are very rigorous questions. So you're like, and you're doing the right thing with presenting all the facts and all the data.
Right. Mhm.
But what's your mental state going through these questions? Like, is it, joy? Is it sadness? Is it misery? What's going on here?
Well, in our head at first it was like our initial response was yes, they're interested enough to actually ask questions. They're not
Right.
we're not all our fears are not quite as terrible as we had thought.
Mm-hmm.
And at that point, we had been waiting slightly over 3 months. So after seeing the SBIR's chief, his statement about the longer you wait, maybe that's a good sign. We were a little bit encouraged,
Mm-hmm.
and but the questions were very deep and they required very detailed answers. And of course, we uh, we had to expose all of our IP, which is okay because they are all sworn, to review the IP and not divulge. They've all taken an oath,
Mm-hmm.
so we weren't too worried. But it's still a little nerve-wracking to have to show every detail.
Right.
And of course, we had designs and drawings, and we had run. Simulations where we actually showed the engine working and we showed all of that. And, in basically we used Blender, which was very easy to learn. And it showed the function, but it didn't calculate. It doesn't have CFD. It couldn't calculate the thrust, but at least it showed them how it worked. And
Mm-hmm.
of course, all our drawings. So that was,
So is
and
Blender a Rocket only software? I have no idea what Blender is.
yeah. Oh, Blender is a design program, graphics design program where
Okay.
you can, draw basically anything. It's used a lot for, entry level animators and things like that, and they can do all kind of animation. But you can also use it to do some, fairly technical drawings, to scale, and then you can simulate those. So it's relatively easy to learn, and it's free.
So you used a
Yeah.
free
Yeah.
software that's used for graphic design
Yeah.
to not only impress, but to simulate a rocket launching where you made a scientific discovery
Yeah.
that basically was worth millions upon millions of dollars, creating a 62% more efficient design for an engine that eliminates or not eliminates, but negates much of the back force or back pressure that's being
Yes.
exerted, making rockets
Mhm.
42, speculatively speaking,
Mm.
percent more efficient using a
Right.
free software.
Right. And the
Wow.
software basically showed
It's that
them,
easy
yeah, the
after
software
7,000
basically
hours.
showed them the function, and the Excel simulation showed them the data on what was happening. And that, so it's again interesting story. And of course extremely nerve-wracking. And then going through this whole process, we
Hmm.
put in the review process, we put in another 1,500 hours working on the answers for those guys. I mean, it was
Nice.
just, you know so finally on August, or it was right around September 1st of 2024,
Hmm.
um, the our program manager just emailed us, big capital letters, "You got it."
Congratulations. You made
Yeah,
it.
and then congratulations.
Right.
And, you know, and then immediately emailed like a day later the actual certificate of award, and then about 2 or 3 days later, our bank account suddenly had this big chunk of money in there. And so uh it was just, it was
Holy
the end
crap.
of one phase and the beginning of another. you
Yeah.
know it's interesting. We talked to our program manager afterwards. He said, "God, it's really great we got this, but why did they have to put us through so much? And then, they gave us the award, I mean, you'd think after they put us through much, we wouldn't get the award, because they find something. And she said, you think about it. She said, that is one of the toughest due diligence processes I have ever witnessed, that, a company an invention has gone through to receive an award.
Yeah.
She said, what they put you guys through, and then the fact that they actually gave you the grant imparted huge credibility to your technology. And she said, I think you'll find in the long run, the process they put you through, that grind will probably be worth more to you than the actual money. And we are finding that to be true. That
Okay.
when we tell people they put us through a 9-month review process,
Yeah.
and we got the award, that in you know in the average person mind is, wow, that they checked it out. This is
Yeah.
not this is not a submission and then a quick They checked it out. So when they gave the grant, they had to be very sure that what we were claiming was true. And
Yeah.
so we're now very thankful that we had to go through the process, that we went through the process and the results, and that,
What
you
were
know,
some of the questions they asked you in the due diligence?
very specifically, they wanted to see the engineering of how we negated this back pressure uh, in the combustion chamber back up into the engines, into the
Hmm.
fuel pumps. They had to see that, and they had to see how that was working, and that we showed them that. We explained that to them. We showed the simulation of the engine and the resultant mass flow rate increase that went through the engine because of that.
Hmm.
And of course, mass flow rate is directly related to thrust. So that would be, and so it- they, I mean, once you have a if once you can prove mass flow rate and the internal combustion, the pressure inside the engine itself, you take those two, and that gives you the thrust. And once they saw that, and once they saw how we achieved it, they were, that's when I say they became very interested. And then, without going into all the other details, they wanted to see in more detail how we did those mechanisms that accomplish that, and
Okay.
we showed them that. And so, and then finally, we kind of got an idea that things were going better, because the very last question they asked us was, "How are you going to commercialize this?"
Yeah.
And that's what that last question, clear up in August of 2024, after 9 months. I turned to Robert, my co-founder, and I said, "Cha-ching!"
Yeah.
And he
So
goes,
what did they so okay, when it comes to like commercializing, what is the profit game for this company? Like how do you guys plan on making money? Because SpaceX is vertically integrated and they have an
"Right,
internet service that they operate, Starlink, right? All these different things for making money. You guys just started. So I want to hear your 2 cents on this while we have.
right, commercialization."
Hmm.
Um, no matter how good an invention you have, and we feel that this is a great invention,
Yeah.
um, to go up against the giants in the industry is, to compete head on head, they would just destroy us.
Yeah,
I mean,
that's
they have huge resources.
cost
Uh, you know,
reduction.
they could be running our engine and using it, and we wouldn't even know it.
Yeah.
How are we going to find out?
How are you gonna prove it either?
And right, right. Um, and this is actually, this is one of our strategies. I'll digress just a little bit. This
Uh-huh.
is one of our strategies in putting in provincial patents instead of actual patents, because the uh, U.S. Patent Office does not reveal provincial patents.
Uh,
They only reveal full patents. So
nice.
we are going to continue to use provincial patents, because a potential theft of our technology is their motivation to do that is greatly reduced because they can't see, and of course we are filing. Since then, we filed other patents and we continue to file provisional patents. So no potential customer, no potential
Competitor.
competitor, right, is comfortable
Hmm.
because we could sue them. So anyway, they what we're going to do um, is we're not going to compete head to head against these companies.
Hmm.
We are eventually going to have our own factory to build and sell the engine as well as the launch vehicle. But right off the bat, as soon as we have MVP, minimum viable product,
Yeah.
we are going to offer partnerships to anybody who will, willing to test the engine, use the engine, produce the engine, sell the engine,
Nice.
because two things. That will get our technology
Yeah.
infused into the industry
Way faster.
relatively quickly. They have the
Way faster.
factories. Yeah, right. It will also give us a revenue stream relatively quickly. We
Yep.
don't have to build our own factory.
And your stuff doesn't
And
blow up as
yeah,
often.
yeah, and then also another thing, it gives us partners.
Yep.
They want to defend the technology
Hmm.
just like we do, and so that's what we're going to do. It's going to be partnerships and licensing agreements right off the bat. Um, you know, uh, just to give you an example, Roscosmos, which is the Russian aerospace company,
Hmm.
uh, has an engine, the RD-180, which is one of the most advanced engines in the world. They license that engine and partnership with other companies, outside of Russia for that. And United Launch Alliance, ULA, the U.S. company here,
Hmm.
bought and used those engines up until just the Ukrainian war. That's how they launched all their vehicles. They were using RD-180 engines, and that licensing agreement gave Roscosmos like about $5 billion in profits because they were selling the engine. I think I'm not sure if ULA actually ended up making the engine themselves under a license agreement, but obviously that infused that technology into
Right.
the industry much quicker than if
Yeah.
Roscosmos, and that's the same strategy. It's a winning strategy, and that's what we're going to use.
I like that a lot, especially when you're designing specific parts of a whole entire vehicle, right? Um,
Right, right,
Now we have a pretty good understanding of how some of your big players in this industry tend to operate. One
right,
of your newest people, right, Elon, and all his fun stuff. Um, Vertical integration has been a huge name of the game, and it's just like very well known for just buying, well, not buying but building.
right.
So I'm excited about this partnership idea more,
Hmm.
as far as the upside for you guys and for them, but also for the other companies that you could potentially work with as well that
Right,
maybe I don't even know or haven't been invented yet.
right,
Um, when it comes to like where you're at now, so let's say on the timeline we're at 2022, you've gotten, and then 9 months from then you've gotten to like 2023 ish,
hmm.
right? Do you have a team now? You're building a team? Are you building engines by now?
Oh,
Where are we at?
right. Well, this is another thing that was very a very one of the barriers for the NSF team to look at. Not only did we not have any aerospace training, we weren't associated with a university, we weren't
Hmm.
associated with a company, and we had no team, no
Yep.
engineers at all.
None.
So, no. So what we did is we took our drawings and we had uh, to a fellow here in Sacramento that's had an engineering company for years, a great guy, and showed him our drawings and said, this is what we have, and we've submitted these to the NSF. Would you be interested in, um, you know, uh, be a partner with us and joining our team to, and we could build the engine in your shop and that type of thing. And he was a little, ambivalent about it. Two
Yep.
guys, knowing nothing about aerospace, but we had told him we had submitted to the NSF and we
Hmm.
were waiting for their response. And he happened to be one of these people that's very interested in NASA, and he was jazzed about the idea of being a part of something.
You got another space
So
generator team.
right, yeah. So
Yeah.
he said okay, and then and of course, then we were formalizing the drawings. We wanted formal engineering drawings of the much more formalized than we had done of the rocket.
Hmm.
So he had, through him, we met several mechanical engineers and aerospace guys, and brought them on board. We showed them, they had to sign an NDA and everything, and they were very hesitant at first because they didn't want to quit their company where
Yeah.
they were working
And
to
feeding their
go.
families and
Yeah, yeah,
yeah.
yeah, they got a family to feed and a house payment,
Yeah.
so what we did was we couldn't hire anybody, so what
Okay.
we did is we came up with this deal: just you keep your job, you work for us part-time when
Whenever.
you get a chance. And soon as we showed them, as soon as they liked that, then
Mhm.
once we had them sign the NDA and they saw the engine, they immediately, yeah, this is a concept that could work. They were excited. So they came on board. So by the time we got the actual okay after the 9 months, we had we had a team of like 7 aerospace and mechanical engineers who had been working for free at their leisure, when they had time, for the 9 months to formalize this drawing concept. And of course, we made iteration changes.
So you have two things going on. You have timeline one and then
Uh-huh.
timeline two, right? So same time over this
Yeah.
9 month period, you have people working on building a thing, and you're like, do we even have money to get it off the ground
Yes.
the entire time?
Yes.
No pressure. What are you talking
No,
about?
no, yeah.
None.
I think
Being
they got us
dramatic.
in the we're the poster children for ulcers of the year. We're just
Yeah.
so bad. Very very tough pressure. So what we did, the guys turned in their hours. We just honor system. How many hours did you work? They would
Hmm.
turn in their hours twice a month, and we would send them these. We would print out a voucher for them that, if we get the funding, you'll get paid for this. And one of the first things, the very first thing, in fact, we did when we got the funding was to pay them for their hours that they had put in, which was not huge, but it was a considerable number of hours. And that you got to give it to those guys because on faith they worked all that time,
Yeah.
and it kind of shows you. We felt, Robert and I felt, that this was sort of a second verification or certification of the technology, because you
Right.
got the NSF, huge due diligence, and then you have these aerospace and mechanical engineers, and they're fully willing to work really
Yeah.
on a bet that this is
Yeah.
going to work, and
Yeah.
that and for free for months. So that we felt was a very big
Yeah. And
validation of
they're the
technology.
ones designing, not designing, but working on the technology directly in their day-to-day jobs anyway. So if everyone's going to know, it's going to be people on the ground more than anything else.
Right. These guys are all aerospace and mechanical engineers, and they are working in, aerospace related or machine shop or different. They all have different jobs, but yeah.
Right. So, okay. So during this time, honor system, they turn it in, you get grant funding, yippee ki yay, after all this time and ulcers and suffering and like grueling and eating dirt, because that's how this happens, right?
Yeah.
Is you got to eat dirt for like a good, however long, 7,000 hours? We're like
Yeah.
9,000 hours into this point.
Yeah, it started to
Something
taste
crazy.
pretty good, actually. Yeah. Well, by
After
this
you get
time
used
we're
to
up
it.
to, yeah, by this time we're up to over 9,000 hours. So
Holy crap. Okay. So once you guys reach 10,000, this thing will be built, right? No, that's how it works. No.
no,
Anyways, so you're at
there's no
2020.
magic number.
That there never will be either. So after
Yeah,
2023, right,
right.
on this timeline, because 2022, 9 months, 2023,
Yeah,
you have a engine and a team and a check and patents.
yeah. Well, actually, we got the check in 2024. We
Okay.
we submitted in 2023. But yeah,
Okay.
that's right. So we have a team, we have some patents, and we pay the team, and now they're uh, making modifications to the engine that they felt were necessary, for the mechanics of it and everything. And they worked on that uh, all of 2020, let's see, remaining 2024, all of 25, and into 26. And now we have the engine. It's all fabricated.
Hmm.
We're actually assembling it. We have the test stand, and we had to get our all the parts that are going to be exposed to liquid oxygen.
Yeah.
We had to get them certified cleaned of impurities on the surface, because something I didn't know, and this is why you have aerospace engineers on your team, that you have liquid oxygen or high pressure oxygen exposed under heat and pressure
Hmm.
exposed to metal, stainless steel. If there's any impurities on the surface, they ignite, and that in turn starts burning the carbon in the stainless steel, and then eventually, if it gets hot enough, the stainless steel and itself oxidizes. So
Oh.
you can't have any impurities. So those parts are all out right now getting cleaned. And
Hmm.
we already got, just in fact 2 days ago, got an email back from the guy, and he said he'll be sending the clean parts to us this coming week. And we've already got part of the rest of the engine. So we're very close to testing right now. Yeah. We're very
Oh,
excited.
that's
Yeah,
cool. That's
yeah,
cool. So
yeah.
so this week you've got like fed some parts and you're just it's coming in and you have a couple more that's gonna come in and then you're gonna put it all together and then where you gonna go to test this thing? Like what's gonna go on from
Well,
there?
well, the engine is a prototype. It's not the
Yeah.
big. It's a smaller version, and we're actually going to just test it right there at the shop.
Nice.
We're
It's
going to
like testing a
be,
car. It's so
yeah,
cool. I love
yeah.
it.
Well, it's in a yeah, it's like in a little industrial park, there. And we're going to do it on the weekend when nobody's there. And
Yeah,
he's got
because
these
it'll be
big
loud.
roll-up doors, and we'll roll it up and put the engine out there. And so and we're thinking about putting up some kind of a blast diverter.
You guys
So
should totally have an Instagram. I would follow it today.
oh yeah. Well,
It just
we have a videographer, and because we're going to be taking videos of it. So
yeah.
we'll
Please
see it.
send it to me because that
Oh yeah.
sounds so
Right.
cool.
Right.
Um,
Well, you can go to our LinkedIn site, US Space, LinkedIn, and it'll all be posted there. So,
it will
and
be in the description at the 0 to 1 podcast. Gotta
yeah,
plug the
yeah,
YouTube channel.
yeah.
So okay, this is a big moment for you guys. So you guys are less than a month away from testing your engine
Right,
and seeing it work potentially.
right.
Potentially. Okay.
Yeah, yeah. And you have to say potentially. You
Potentially.
never promise. It's
Never.
rocket science. You never say you don't overpromise. You never do that. You can't. You have to say, I'm so glad you said that, because
Yeah.
that's a very big factor that you always have to consider
I mean,
potentially.
I am so entrepreneurship in general is it's a bunch of calculated risks. It's
Right.
chess where every so often like the little pieces will flip or a table will flip or whatever, right? Or something will
Mm-hmm.
fall out the sky and something's gonna break or
Mm-hmm.
something's whatever, right? The
Yeah.
amount of times where I've gone, this is for sure what's gonna happen, and then I'm wrong. Oh,
No.
I'm conditioning possibly.
Mhm.
It's a thing. I
Right.
don't guarantee anything anymore. Um,
Right. You can't overpromise. In fact, you
no,
really shouldn't even promise. Just say, "Hey, this is rocket science. What we know is these aerospace engineers and the
yeah,
NSF looked at this, and they say, "Hey, this could work."
it's looking pretty good.
And simulations show that it could
Yeah,
work, but you never know.
yeah.
So that's what our testing is going to find out.
Yeah. And if it goes up in flames, it'll be spectacular. So
4th of July might be early this year. You don't know.
it'll be in June. No big
Uh,
deal.
yeah, I hope not.
The calendar's wrong. It's not the day. It's just the calendar. Okay. So Roland, thank you so much for your time being on here at 0 1
Yes, sir.
Podcast.
I
I think you
appreciate it.
have a huge story that's going to impact a lot of people. And especially when it comes from 0 to 1. I mean, retired teacher to rocket space CEO,
Mhm,
designing an
mhm,
engine that's blowing records out the water when it comes to being
mhm.
62% more efficient on preventing back pressure and 42 to 43% more efficient when it comes
Yeah.
to like helping efficiency overall.
Yeah.
This thing's gonna change the world.
Right.
And
It
like,
could.
thank
It
you so
could.
much.
Yep.
You
Yep.
know,
Yeah. It could be it's definitely an October Sky 2 movie potential. And we don't really pat ourselves on the back, but
yeah,
also actually it's a pretty interesting story, and I think we hope that it's an encouragement to those people who have an idea and they think I could never do this. You can do it. It takes hours. You have to go through a lot of emotional roller coasters, but it can be done. And more power to all of you. If out there, if you have an idea, go for it. That's what I say.
go for it. Wise words. Thank you so much for your time. Really appreciate it.
Yes,
Anything you
sir.
want to recommend to the people before we close it? Any book recommendations, any podcast recommendations, anything at all? Floor is yours.
Actually, nothing more right now other than if you check our LinkedIn site, we will have updates on the testing. We might have the data stream for that and video for that by the end of June. Hopefully,
Ooh,
it will be by the end of June,
that'll be good.
and that's the situation.
If someone
But
wanted to get into rocket space and aerospace from your level where they were at zero,
yeah.
where do you recommend they start looking?
Oh, oh yeah, good. Because there are a lot of people. We found out thousands, really,
It's
people
a
are
big
interested
industry.
in aerospace industry. First of all, you can go online and just there are absolutely endless YouTubes on aerospace technology, rocket engines, launch vehicles. There are actually quite educational. There's all kinds of online courses you can take, and then of course you can go apply if you feel that if you're older and you want to go back to school, or if you're young, you can go back. And there's aerospace departments in almost every university.
Mhm.
In State College in California, and really across the country, aerospace is becoming a huge thing. So the ability to learn is there. The resources are there, but again, you got to put in the hours. People will say, "Oh, well, overnight, U.S. space is developed." No, it's
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 always
been
overnight. That's when they care
right.
about it, right? It's never
Yeah,
like it's over years of you working and crying and
right.
like having the ulcers and the 10,000 hours and 20 plus. It's insane.
Yeah.
Um,
By the time the engine actually sort of emerges, it'll probably be 27, which means that's 10 years.
10, I mean, by then you're technically a master in your field, right? Isn't that how that works out? You got 10,000
Well,
hours.
yeah, a very interesting gentleman we know who we met who works for Lockheed
Yeah.
asked us, well, what is your training, and what's your diploma? What did you get? What's your degree in?
Yeah.
And I pulled out the notice of award from the NSF, and I held it out to him, and I said, "This is our this is our degree right here.
Yeah.
This should, there's a lot of aerospace engineers and people in the world who would, you know, they would die to get one of those, and
Yeah.
we got one, and that's a very rare
Wow.
thing.
Is
Yeah.
there anyone, any like channel, any YouTube channel, anything that you recommend people that's like a place where you personally go to find and learn research on?
Right. There's so many that it's very you can I I would suggest if you don't have it, get chat or Grok or one of the others, and ask them to
Hmm.
do a search for you where you can learn about aerospace and aerospace engineering,
There we go.
and the math required and all of that, and it will outline a course for you. It's absolutely fantastic. And of course you can uh, uh, there is a free version of chat, for example. We have a paid version, which I feel is better, but the free version of chat could outline an entire curriculum for you where you can go.
Yeah.
It's there, and it's actually much easier to access now than it would have been years ago, for sure.
That's awesome. I think one of the big themes from this episode and from someone with your story is not the technology you have, it's how you use the technology you have. Because I mean,
Right.
you started with with Blender, a free service, and then ChatGPT, and you're like, you can use the free version.
Yeah, we
Okay.
did at
And
first.
then
We used it for
recommending
free for
YouTube
years. Yeah.
Learning, and it's
Yeah.
just, but and then you pull out your, NSF, like we got that grant, like that's a
Yeah.
huge story. It's a huge win.
Yeah.
Honestly, I'm excited to see where you guys go from here, hopefully to the stars and
Right.
back. But
Thank
if it
you.
ends up being on the ground, like you guys did something incredible either way. So
Yeah. Yeah.
I'm proud. Um,
Yeah, we're just we of course now we really hope it works, and we
yeah.
feel of course that it does work, it will work. Um, but no matter what happens, I feel the whole experience was completely worth it, and
Mm.
and will be as we progress. So, yeah. Thanks, Justin. This is
Thank you,
very
Roland.
nice of you to have us on board. And yeah, it's great to just relate to people, and also just to hopefully again it not only the technology but the hopefully it will encourage other people to get into aerospace and really any other thing that they want to get into where they especially if they feel, "Oh, I don't know anything about that." No, not that's really
Yeah.
not the case.
Let me stay
Yeah.
in my lane.
Right.
No, don't
No.
even. Just
Yeah.
and be curious. Like lead with your curiosity.
Right. Right.
I think it's a huge. It honestly, it's like the one thing. Curiosity and being social are like the two things that help lead us to be
Right.
the most intelligent, the
Right.
most capable versions of ourselves. So I think that and self educating, being an autodidact and continue learning, will help kind of
Right.
push things forward because at the end of the day, we're all still here.
Right.
Um, so I'm excited. I'm excited. And honestly,
Yeah.
please come back in like the next couple months. Give us an update.
We
I
will.
would
Yeah.
love to hear more about your story.
Right.
But thanks so much for your time, Roland. Really appreciate it.
You're welcome.
All
Thank you
right.
very much, Justin. Thanks
You're
for
welcome.
having us aboard. We really appreciate it.
All right. And that concludes this episode.